Chapter 3, Section 3, we're talking about inequality regions. Now, if you remember what we just did in 2.7 and 2.8 where we graphed inequalities, Chapter 3, Section 3 is graphing multiple inequalities on the same line and finding out where they overlap. And that's all it means, okay? And let's just have a quick reminder. We have the symbols less than or equal to and greater than or equal to. And what we have to remember about these symbols is that they have a solid line, okay? And what you have to remember about less than and greater than is they have a dotted line, okay? And you need to remember that in order to graph and in order to identify which line goes with which. So is the line solid or dotted are the two questions you have to ask, and is the shading above or below, okay? If it's a solid line, that means you're going to have greater than or equal to or less than or equal to. If it's a dotted line, that means you're going to have greater than or you're going to have less than. Is the shading above? That means the symbol has to be greater than or equal to or greater than. Is the shading below? That means you're going to have less than or less than or equal to. Okay, now I would definitely write those down. That way when you're working on it, you can go back and refer to those things when you are doing your assignment. Okay, so the steps to graphing or identifying regions is, first thing you're going to do is match the equations with the correct line based on their slope and y-intercept. If you remember, slope is the rise over the run, okay, or the change in the y, change in the y over the change in the x. And the triangle, if you remember, just means change. And if you remember, y is your up or down, and your x is your left or right. Given a region, find the equations that make it up. Borders. So if I'm looking at a region, I have to first look for the borders, and then identify which equations match with it, and then replace the equal signs with the correct inequality symbol that represent the given region. Now, a lot of this probably means nothing to you until I show you an example. So let's go ahead and do an example now. Okay, so here's my large graph with lots and lots of inequalities. What I need to do is decide what the lines are and what I am going to do, which of the lines match up with which equation, and then which region it makes up. So let's look at our steps. First things first, match the equations with the correct line. So I have to look at these equations, look at the green line. Match the equation, one of these four equations has to go with that green line. We're not looking at the shading yet, we're just matching the equations. Well, if I look, this is a horizontal line at y equals 1, 2, 3, 4. At y equals 4. So I'm going to take my y equals 4 and I'm going to match it up with the green line. Then I have another line, a red dotted line, right here. This is a vertical line, and if you remember, the equation of a vertical line is x equals. Well, which one is x equals? X equals -6 goes with the red dotted line. Now, the reason it's equal is because we know it's dotted, so it's going to have to be less than or greater than, but right now we're just identifying the equations of the actual lines. So now the two equations that I have left are these two equations, and the two lines I have left are the purple line and the blue dotted line. So I know that the slope of this line is negative, and the slope of this line is positive. How do I know? Because of the m. The m in the first one is -2. The m in this one is 1. So which one of these has a negative slope and which one has a positive slope? Well, I know the pink line has a negative slope because it's going down. So I know that this one has to go here. And does that make sense? Does it have a y-intercept of 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it sure does. So that's my line for here. And this one, does it have a y-intercept of -4? Right here? Yep, it sure does. So I'm going to match that one up here. So now I'm matched up. So now I have to identify regions and create a system of inequalities. You're like, what in the world are you talking about, Mrs. Numbers? Well, let's look at this like this, okay? So let's say I ask you, okay, look at region 4. look at region 4. Region 4 is the light blue region on this graph, the light blue right in the middle, okay? Now, the first question I asked myself, if you remember back on my steps, is given the region, which we just had region 4, find the equations that make it up. What borders region 4? And the hard part of this is you have to ignore the x and the y-intercept unless they are a part of the actual equations, which they're not in this case. So the blue dotted line is a border, the pink line is a border, the green line is a border, and the red dotted line is a border. So all 4 lines make up region 4 right here in the middle. So once I find out, I'm going to write all those equations down, which is what I did over here. I wrote all of the equations down, okay? And then I have to replace the equal sign with a symbol. And here's where you use your cheat notes that we wrote back in the beginning. Okay, how do I know which symbol to use? Well, if the border is a solid line, I'm going to use less than or equal to or greater than or equal to. If it's shaded above, I'm going to use greater than or greater than or equal to. I have to narrow it down. So let's look at what I'm talking about. Okay, region 4, y equals 4. That's the green line right here. Is it a solid line or a dotted line? It's a solid line, which means it has to have either less than or equal to or greater than or equal to. Well, is region 4 below the green line or above the green line? Region 4 is below. So based on the fact that it's a solid line and it's below, y equals 4 is y is less than or equal to 4. Because the blue region is below and it's a solid line. Now we have to replace this equal sign with an inequality. So y equals x minus 4 we know is this blue dotted line. And I just said it's dotted, so it has to be less than or greater than. Well, is region 4 above the blue dotted line or below the blue dotted line? Above the blue dotted line, which means I have to replace this equal sign with a greater than x minus 4. Now let's look at this equation, the next border. Y equals negative 2x plus 10. That is the solid pink line right here. And I just said solid, so I know that my inequality has to have an equal to. So is the blue region, the region 4, is it below the pink line or is it above the pink line? It is below and it's a solid line. So if you look at your cheat sheet, below and solid line mean less than or equal to. So equation 3 becomes y is less than or equal to negative 2x plus 10. Then the final equation, x equals negative 6, is the red dotted line. Is the blue region 4 greater than or less than the red dotted line? Remember, greater than numbers are over here, less than numbers are over here. So we would say it's greater than, and it cannot be equal to because of my red dotted line. It's dotted and it's above, or in this case it's not above, it's just greater. You think about this line, where are the x values bigger? Over here than there are over here. So we would say this side's greater, this side's less. So x is greater than negative 6. So this set of inequalities, if you graph them and shade them all in the same graph, they're all going to overlap in region 4. And that's exactly what we want. We want them to overlap in region 4 because that means this is a system of inequalities that creates region 4. Okay, let's look at another one. And I'm going to drag this. So this example is 1U2. Well, what in the world does U mean? Well, 1U2, U just means union or and. So what I want to graph here is regions 1 combined with region 2. So let's look and find region 1 and 2. Let me erase my marks that I made earlier. Region 1 and region 2, well, region 1 is this like lime green and region 2 is like the little limer green. So it's the two lime green areas over here. But if you combine them, It's that entire area. And I'm going to go ahead and highlight what I mean. Region 1, Union Region 2 is this entire area here. It's all of this. Okay? So I have to think of that as one area. As soon as I union it, it means it's combined. So I have to now think, okay, next step, once I identify the region, what equations border that region? And you can even think of it like land. Like what lines border your land? Well, the red dotted line, the green line, and the blue dotted line border this yellow 1 union 2. So those are the 3 equations that I wrote down. Then I have to decide, okay, I have to replace the equal signs with inequality symbols. So let's go ahead and do that. So I'm going to x equals -6. Well, the yellow line is more than, but it's dotted, so that means x is, oops. Go back to the pen. X is greater than -6. That means everything over here. And then as soon as we go to y equals 4, it's going to be greater than, but it's a solid line, so we would say y is greater than or equal to 4. And finally, my dotted line, my blue dotted line, is the yellow part, is it above or is it below? It's above, so we would say it's greater than. Y is greater than x minus 4. How do I know it's greater than? Because we have a dotted line and because it's above. You must replace the equal sign with an inequality symbol that represents the shaded region. If you graph all 3 of these like you did in 2.7 and 2.8 and then find where they overlap, you would get region 1, union region 2. I'm going to do 2 more examples and I'm going to go a little faster, and this one doesn't give me the equation, so I actually have to come up with them. Okay, now I'm going to erase what I had so that you can see it. So the first one is region 4, union region 5. And if you have to, you can highlight, draw the picture, and you can highlight what we're talking about. 4 and 5 is this inside triangle right here. Okay, that's these 2 combined. So we have the green area right there. So I have to think to myself, okay, what equations border the green shaded area, regions 4 and 5? Well, the red dotted line hits it here. The green solid line hits it here, and the blue dotted line hits it here. We ignore the purple line because that's not a border, it just goes right through the middle, so we ignore it. Only the borders. So I have to think, okay, 4 union 5, I'm going to write those 3 equations down. The red dotted line is x equals, change back to a pen, x equals -6, and then I have the green line, y equals 4, and then I have the blue dotted line, which is y equals x minus 4. So now that I have those 3, I have to think, okay, replace the equal signs with inequality symbols. Well, the first line, the red dotted line, it's going to be greater than, so you can either erase or you can replace, and it's going to be greater than. Okay? The green solid line, the shaded region is below it, and it's a solid line, so I'm going to replace my equal sign with a less than or equal to. Then my blue dotted line, the green shaded area is above my blue dotted line, so I'm going to replace my y, or my equal sign, with greater than. And finally, region 5, union region 7. Well, let's erase what I have, 5 and 7. So that would be this area right here. 5 and 7 is this area right here. 5 and 7. Okay, I'm not going to shade all of it in, but you see the blue shaded area that I just shaded in. What lines or what equations border that blue shaded area that I just created? Well, write them down. I have y equals 4. I have y equals -2x plus 10. Now I have to replace the equal sign with an inequality symbol. Well, since this blue shaded area is below the green solid line, I'm going to replace the first equal sign with a less than or equal to. And the second one, the purple one, it's above the line. It's the sky part of the mountain, above the line. So it's going to be greater than or equal to, because it's a solid line. That is the first part of Chapter 3, Section 3.